Assalamu alaikum أصدقاء الطلاب. Welcome to Chemistry Online with Mr. Ahmed Sulaiman. Today we are going to continue our lesson 20.2 oxidation numbers. We studied how to calculate the oxidation number. Today we are going to study the oxidation number, which changing from reactant to product in chemical reaction. It means you have reactants changed into products. What change happens for the oxidation number? And we can identify whether the atom oxidized or reduced and which is the oxidizing agent and reducing agent as well. First, look at this experiment which has reaction of redox. If you bring a piece of metal like copper, this is a copper, and put it in a solution of silver nitrate solution, you place a copper wire in it and leave it. You will see that silver nitrate AgNO3 reacts with copper metal and yields CuNO3 by 2 plus Ag precipitated. Look at the precipitation of silver. Okay, we need to calculate the oxidation number of silver before and after the reaction, or we can say in the reactants, in the products, what change happens. Also, we need to see what change happens in copper before and after, or in the reactant and in the products. First, Ag was positive 1 here, because NO3 polyatomic ion is negative 1, so silver is positive 1, we know that. Here, silver is in the form of monatomic metal, so it's 0, the overall charge 0. Remember the rules. So it changed from positive 1 to 0. What happens here from positive 1 to 0? What happens to silver here? The oxidation number increases or decreases? Decreases. It means it's oxidized or reduced. It decreased means it gains electron, so it's reduced. Okay, this is silver. What about copper? Copper here is 0 because it's in the form of metal, and here is positive 2 because NO3 is negative 1, but they are 2, so NO3 negative 2, so copper is positive 2. What change happens here from 0 to positive 2? Increases. The oxidation number increases means oxidized. Look, copper oxidation number was 0, changed into positive 2, and it's oxidized. But what about other elements in the reaction? Look, we said that Ag changes from positive 1 to 0, so it's reduced. Copper is changing from 0 to positive 2. The oxidation number increases, so it's oxidized. We can say this reaction is redox reaction. What about the others? Look at nitrogen, it was positive 5. You can calculate it. We got how to calculate any element in a compound. So, nitrogen is positive 1, nitrogen is positive 1, no change. Oxygen negative 2, oxygen is negative 2, no change. Other elements, they don't change, so nothing happens for them. We are explaining what happens to the elements that are changing in their oxidation number. From that, you can define the oxidation and reduction reaction, or the terminology of each of them, oxidation process and reduction process, which is the increase in the oxidation number of ion or atom indicates oxidation. The decrease in the oxidation number of atom or ion indicates reduction. We got that before. Look at what happens here. We are burning a kind of metal here. What happens here? I told you before, burning means gaining oxygen or oxidation. So if you have a metal burn, it means it gains oxygen. It means undergoes the oxidation process. And also the substance that make oxidation, we said that has an increase in oxygen number. We said that. So this metal here, we can say that it burns, it means oxygen number increases. Let's answer this problem and see how can we calculate the oxidation number for the elements and identify what changes happened to each element, to identify what element oxidized, what element reduced, and also to identify the oxidizing agent and reducing agent. Look at the first example, Cl2 gas plus 2HBr aqua solution yields H2HCl aqua solution plus Br2 liquid. First, you have to identify the concepts in your mind. We said that before. The increase in oxidation number means oxidation. The decrease in oxidation number means reduction. And the substance that oxidized in the redox reaction means reducing agent. The substance that reduced means oxidizing agent. Let's answer the question. Chlorine is a molecule uncombined. You remember the rules. If it's uncombined, means it's zero overall charge or oxidation number. What about HBr here? You don't need to calculate the charge by using coefficient. You have to know that. Look at HBr here, coefficient for balancing equation only, not for calculating the charge or oxidation number. Recall hydrogen is positive 1 and bromine is negative 1. We know that. So we have the charges here, easy. What about HCl? The same, H is positive 1, it's not a hydride, it's not a special case, positive 1. And the chlorine is negative 1. Br2 here is uncombined molecule for a single element, so the overall charge 0 like chlorine. What change happens here? Chlorine was 0 and changes into negative 1. No change in hydrogen, leave it. What about bromine? Bromine was negative 1 and changes into 0. What happens to each of them? Chlorine 0 to negative 1. It increases in its oxidation number or decreases? It decreases. So it's reduced. What about bromine here? Negative 1 changes into 0. It increases in its oxidation number. It means oxidized. So we can say here the substance here is reducing agent. And chlorine here reduced, so it's oxidizing agent. Okay, so easy, I guess. This is the answer. The element chlorine here reduced, as we said, so it's oxidizing agent. The bromine is oxidized because it changed from negative 1 to 0, so it's reducing agent. Let's move to the second example. Use the rules to calculate the oxygen number and identify which is oxidized, which is reduced, and also to identify what is the oxidizing agent and reducing agent. What about carbon here? It's an uncombined element, so the overall charge is zero. Oxygen also uncombined molecule, so the overall charge is zero. What about carbon dioxide? Let's calculate. Oxygen is -2. Remember the rules. It's not a special case. So -2 times 2, because there are two oxygen ions here, so it's -4. What we have to make here for carbon to make the overall charge 0, because it's a compound, +4. So carbon is +4. What change happens here? Look, carbon was 0, changes into +4. So oxygen number increases. Increase means oxidized. And the carbon is reducing agent. Oxygen here changes from 0 to -2. It decreases, so it's reduced. And oxygen here is oxidizing agent. I think it's clear. This is the answer. So carbon is reducing agent and oxygen is oxidizing agent. If you have like this equation and we need to identify oxidized, reduced atoms and oxidizing and reducing agent as well. Oh, it's difficult. No, it's not difficult. Don't be afraid of like this reaction. Even all of this reaction, it's easy. How? First, you have to assign the oxygen number of each element. Calculate the oxygen number of each element. This zinc is 0 because it's an uncombined element. Oxygen here is -2 times 2 -4. Okay, and we have to make here +4 for manganese to make the overall charge 0 because it's a compound, so Mn is +4. Here NH4Cl, don't concern this coefficient, but NH4Cl, what happens here? Cl is -1, we know that, okay, and hydrogen is +1 times 4, +4, and here -1. What we have to make here for nitrogen to make the overall charge 0 because it's a compound, +1 -1, +3, so we have to make here -3, so nitrogen is -3. Let's move to zinc chloride here. Zinc is +2, we know that, and chlorine -1 times 2, -2, easy. Mn2O3, oxygen is -2 times 3, -6. So we have here to make +6 for manganese to make the overall charge 0, but there are two manganese ions, so each one has +3 only. NH3 is a compound, ammonia, and has H +1 times 3, +3 here, and nitrogen must be -3 to make the overall charge 0. The last one, which is water, oxygen is -2 and hydrogen +1, we know that, times 2 +2, but each one has the value of oxygen number +1. Now we calculate everything here, but we need to identify which element oxidized, which element reduced. Look at this zinc. Zinc here was 0, changes into +2. It increases in its oxygen number, so it's oxidized. What about Mn? Mn here, +4 changes into +3. The oxygen number decreases, so it's reduced. What about oxygen? No change, -2, -2. What about nitrogen? -3, -3 is the same. What about hydrogen? +1, +1, the same. What about chlorine? -1. -1 also no change. Other elements don't change, so nothing happens for them. Only the change for zinc and manganese. It means the zinc oxidized, it means it's reducing agent, and manganese reduced, it means it's oxidizing agent. That is the answer. It's easy now. So first you have to calculate the oxidation number for each element here. Then identify what changes happen. You will see that zinc oxidized, changing from 0 to +2, and manganese reduced, changing from +4 to +3. And you can identify easily zinc is reducing agent and manganese is an oxidizing agent. Let's see this example as well. We have here a compounds HNO3 plus H2S yields NO plus H2O plus S. I don't concern with the coefficient here, it's related to the balance, but we need to calculate the oxygen number for each element. We'll do the same procedures here. You calculate hydrogen, nitrogen, oxygen number for each, also hydrogen, sulfur, and each element as we said before, and you will see that the change happens here for nitrogen. It was +5, changes into +2. The number decreases here, it means reduced. And change happens here for sulfur. -2 changes into 0. It means the number increases. It means oxidized. What does it mean? It means sulfur, because it's oxidized, so it's a reducing agent, and nitrogen reduced, so it's oxidizing agent. What about others? No change in hydrogen or oxygen in both sides of the reaction. This is the answer of this question. And this is the end of our lesson today, part 2 of 20.2. Thank you, Ashraf.